Hi, students. Let's look at this question here, which is on hypothesis testing, taken from the year 2012, paper 2, question 6 of the A-level paper. So, on a remote island, a zoologist measures the tail length of a random sample of 20 squirrels. In a species, a squirrel is known to the tail length have mean of 14 cm. Okay, so what does this mean? It means that everyone know that the tail length is 14 cm. Okay, so that should be your null hypothesis. That's the population mean. Okay, so this is mu 14.0 cm. So she carries a test at 5% level of significance or whether the squirrel island have the same mean tail length as a species known to. Okay, so she assumes that the tail length of squirrel on the island are normally distributed and the standard deviation is 3.8 cm. So this is actually our population standard deviation. It's not the sample's standard deviation. Okay, so state the appropriate hypothesis for the test. So this case here, what we know is H0. Everyone know it to be 14 cm. Okay, 14 cm. Then this would be a two-tail test. She wants to see whether it's actually 14 cm. So subsequently, the sample mean is denoted by X bar. She collected 20 squirrels, right? And essentially, she got the sample mean. The 20 squirrel, the sample mean tail length is actually X bar. So now, use an algebraic method, calculate the set of value of X bar for which the null hypothesis will not be rejected. Meaning to say, do not reject H now. Okay, so we're going to write down everything down for the setup of the question. So if n is 20 squirrels, then we know that the population standard deviation is 3.8 cm, right? So then after which, we also know that the level of significance is 5%, right? Sample mean is X bar, that's what we need. So under H0, write down the test statistic. This would be a z-test, so it's X bar minus mu over sigma square over n, normally distributed. Don't need to use CLT because the population is already normally distributed. Okay, so that's the case there. Then what we need now is to not reject H0. Yeah. So this in the middle, this is always H0 is true. The closer you are to the central will mean that H0 is true. So this two tail here, we will have, because it's two tail, so this will be 2.5% and this will be 2.5%. Okay, so we're going to find the z critical here, and this is the z critical here. Just key in calculator to find the z critical. From here, what we know is you could just second inverse norm here. Remember, it's 2.5% on the left or right, so you could use left or right. So it just be symmetrical per meter, so it's negative 1.95996. Okay, so this will be negative 1.95996. You can use center, but I don't encourage students to do that because usually students will have problem. There are a lot of careless mistake I've seen enough to just ask students not to do it. The center, you have to use 95%. Okay, so that's that. Then what we're gonna do next is actually just find. Since H0 is not rejected, okay, we know that the z statistic will be between 1.95996 and negative 1.95996. So you don't need to stray away from the middle. So this middle here, your z-stat should fall within this region here. Okay, so that's that. Then what we're going to do next is just going to standardize it. So this case here, we have X bar minus the 14 cm, then of which square root 3.8 square over 20, 1.95996. I'm going to just multiply throughout everything with 996 multiplied by square root 3.8 square 20. Then this will be X bar minus 14 between 1.95996 square root 3.8 square 20. Okay, then just add 14 to the entire inequality. So once it's done, just add 14 throughout. That will be X bar 12.3346. Then this will be 15.6653. Okay, from here we can just round out to 3SF. Doesn't matter. Okay, so 15.7. Okay, that's it. So that's how you do this question here. So let's look at the next part here. So 5 years later, the zoologist took a sample of 20 squirrels and found that the X bar now is 15.8. He wants to make a claim that the mean is at least mu. No, he doesn't want this claim to be rejected at 5% level significance. Find the range of value of mu not that he can claim. Now, so this is a one-tail test. So this can be a bit slightly confusing. So just hear me out. Part 3. Now, he wants to claim that mu is at least mu naught. Okay. So you're at least mu naught. So and then he do not want that which is claimed to be rejected by he doesn't want his claim to be rejected. So essentially this is a one-tail test. The alternate hypothesis will be less than mu naught. Okay, so this will be you are testing mu at least more than mu naught for the what do you call it, the at least mu naught here. So you might as well just take the lower bound, which is equal mu naught. So that's the whole idea. Okay, this is a one-tail test. So we in our syllabus we don't really write at least, right? Okay, so you can actually write at least like that, but we just write the mu naught to be equal. So it can be very confusing that way. Okay, so now everything is the same, 20. Then X bar is 15.8. Okay, so this is his claim. This has to be his claim. So this is it. I'm using the same distribution, so I don't think I will want to write them under H naught. Everything. Okay, maybe I just write down under H naught here. There you go. So this is what's going on. Now he doesn't want his claim to be rejected, so just take note. This is what we're gonna do. Here will be this guy. In the middle is always H naught is true. Okay. Then what you want is actually how many percentage? 5%. So you do not want to. You will be, his claim will be rejected at this juncture here. So this is your 5% over here. So this is a Z critical. Okay, so that's it. So since H naught is not rejected, what you want is actually the Z statistic to fall within this region. So this region is where H naught is true, more than Z critical. Okay, so similarly, now you just use your calculator to find the Z critical. You inverse norm, second distribution, inverse norm 5% on the left. Okay, that's it. So just key in negative 1.64485. There you go. So Z stat will be 15.8 minus mu naught square root of S square, which is 3.8 square over 20. Then just solve this inequality over here. So this is what we get. You have got mu naught less than 17.2 GSF. Okay, you can put a equal sign is fine, but this is fine as well. Okay, so that's that. So part 4, in order to carry out this test, the zoologists have to make two assumptions. Say that these two assumptions. So firstly, I think the first assumption is fairly okay, meaning to say, because you're only taking a sample of 20 squirrels, you still have to assume that the population is still normally distributed. Okay, and then secondly, which is a quite important one, which is the spread. So the population standard deviation will remain the same, because if it's not the same, then this test result will not be valid. So I think these are the two important assumptions we have to make in order to be able to make sure that the test result is valid. So this is how I write it. So if you have any questions or comments at all, please do let us know, and I'll see you in the next question.